we'll be talking about rational functions. Am I sharing my screen with you right now?
Yes,
Okay,
ma'am.
good.
Yes, ma'am.
So a rational function is given by the form r of x is equal to p of x all over q of x, where p and q are element or are polynomials. And you also have to remember that q here should not be equal to 0, because if this happens, your function will be undefined. Now, there are different main parts that we will be looking for in rational function. So first, we have the domain. So the domain, these are the possible values of your x. To get the domain, just simply take or find a value of x that will make your function undefined. Next, we have the intercepts. Okay, let me write it here. We have the intercepts. That is the x and the y intercept. For the x-intercepts, you'll just have to substitute or to let y be equal to 0. For the y-intercept, you'll have to suppose that your x is equal to 0. Next, we have the zeros. So for the zeros, it's not necessary to really solve this one because whatever your x-intercept is, whatever the value of your x-intercept, whatever the value of your x in the x-intercept, that will be your zeros as well. Next, we have the asymptotes. For the asymptotes, we have two types: the vertical asymptote and the horizontal asymptote. So for the vertical asymptote, I'll just write it here, VA. The vertical asymptote, these are the restricted values of your x. So whatever it is that shouldn't be a value of your x in the given function, that will be your vertical asymptote, provided that no common factor exists for the numerator and the denominator. Next, we have the horizontal asymptote. For the horizontal asymptote, we have conditions that we must consider. If the degree of your numerator is less than the degree of your denominator, this means that y is equal to 0, or your horizontal asymptote is 0. If the degree of your numerator is equal to the degree of your denominator, this gives us the horizontal asymptote, or y is just equal to a over b. A and b are the leading coefficients of your numerator and denominator. But if we have here d, or the degree of n, is greater than the degree of your denominator, this means that the horizontal asymptote does not exist. Now, after you find the domain, the intercepts, the zeros, the asymptote, we also have to look for the wholes of our function, or the whole. The whole or the wholes, it is simply the remarkable discontinuity in your function. So how to solve the whole? You just have to check first if there is a common factor in your factorized form for your function. Now, if you can see a common factor, then you go solve for x. But if you cannot see your common factor for numerator and the denominator, then this means there is no whole in the given function. So let's begin by having an example. Let's try to solve the rational function f of x is equal to x squared minus x minus 6 all over x minus 3. So we can simply factor out the numerator. Okay, let's factor out or rewrite the numerator and the denominator in factored form. For denominator, that's given x minus 3 because its only factor is itself and 1. For the numerator, let's have the factors for our first term and the third term. In this case, our first term is x squared. So the common factor, the factor of x squared is x times x. Now for negative 6, we have to think of the possible factors of negative 6 that once added together, the result will be negative 1 since the numerical coefficient of x here is 1. Okay, so can you think of factors of negative 6? We can have
Um,
negative 6 and 1, 6 and
positive one,
negative 1,
positive 5, ma'am.
positive 5, factor of negative 6. Factor of negative 6.
Today. Negative 3, ma'am.
Okay, negative 3 and 2 or 2 and negative 3. So again, our aim, these are all factors of negative 6. But our aim is when these two are added, the result would be negative 1. So negative 6 plus positive 1, the answer is negative 5. So we cannot use that. Positive 6 plus negative 1, the answer is positive 5. We still cannot use this. Negative 3 plus positive 2, the answer is negative 1. Negative 1 is our middle term, so this means the factors are negative 3 and 2. This is now your factored form of your function. So x squared minus x minus 6 over x minus 3 can be written as x minus 3 times x minus 2 all over x minus 3. Now let me erase this to get more space. So first, we'll go and look for the domain. Alright, the domain. So take out the denominator, that's x minus 3. You equate that to 0. Now we'll use the addition property of equality, or we'll have to add 3 from both sides. X minus 3 plus 3 is equal to 0 plus 3. This gives us x is equal to 3. Now this value of x is your restricted value. What do you mean by restricted value? So this cannot be part of our domain. Why? If you have here a denominator x minus 3 and 3 will be substituted to x, then we have 0. So this becomes the numerator x squared minus x minus 6 all over the denominator 0. That is undefined, which clearly contradicts to the definition or the conditions of rational function. Now your domain will look like this. You start with a bracket, write down x is element of real numbers where or such that x is not equal to 3. So you can substitute any values to x as long as it is not equal to 3. Now let's have the intercepts. So for the intercepts, let's begin with the x-intercept. X-intercept or intercepts. So first, write down your function. From f of x, we will replace that with y. This becomes y is equal to x squared minus x minus 6 all over x minus 3. From our instruction in here that if we look for x-intercept, you let y be equal to 0. So this becomes 0 equals x squared minus x minus 6 all over x minus 3. Now we need to eradicate the denominator. That means we multiply both sides by the denominator itself, which is x minus 3. Now let's continue that here. X minus 3 times 0, that is just equal to 0. x minus 3 and x minus 3, that's cancelled. So we are left with x squared minus x minus 6. Take note that x squared minus x minus 6, it's just the same with writing this one into its factored form, x minus 3 times x minus 2 equals 0. Now we'll have to separate these factors. X minus 3, you equate that to 0, and x minus 2, you equate that to 0. Right, this should be positive 2. This is positive 2. I forgot. None of you have noticed, I guess. This is positive 2. Okay, using the properties of equalities, we have our x is equal to positive 3 and x is equal to negative 2. This means that our x-intercepts are given by 3, 0, and negative 2, 0. Do you follow? Do you
Yes,
follow?
ma'am.
Okay. Now let's continue for the y-intercept. Y-intercept. Okay, let's write down first the function. Replace f of x with y. So y is equal to x squared minus x minus 6 all over x minus 3. Now let's set or substitute 0 to all of our x. This becomes 0 squared minus 0 minus 6 all over 0 minus 3. So we are left with negative 6 divided by negative 3, and this gives us the value of our y is positive 2. So your y-intercept will be 0, positive 2. Now we're done with the domain as well as with the intercepts. Next is we'll have the zeros. But before we proceed to the zeros, take a look at the values of our x-intercepts in here. We have 3, 0, negative 2, 0. We can consider this, but notice that it is restricted in here. 3 should not be part of the domain. So x equals 3 will not be part of our x-intercepts, only the x which is negative 2. So we only have one intercept here, negative 2, 0. And for the zeros, we'll take the x value on our x-intercept, which is equal to negative 2. So this will be your 0. Next, let's go and look for the asymptotes. Asymptotes. Okay, so for the asymptote, let's begin with the vertical asymptote, or VA. I'll just write it here, VA. Okay, I'm writing here VA. So for the VA, before we can write down the restricted values of our x, we need to see if there is no common factor of our function. But in this case, we have on the numerator x minus 3, on the denominator x minus 3. There is a common factor, which means no vertical asymptote or exist, or there is no vertical asymptote. Now let's have the horizontal asymptote. So for the horizontal asymptote, let's compare the highest degree for the numerator, that is 2, and the highest degree for the denominator, that is 1. Now 2 is greater than 1. So let's go and check that in here. Degree of the numerator is greater than the degree of the denominator. What do we have here? Okay, none. This one, the degree of
None.
numerator is greater than degree of the denominator. This means that the horizontal asymptote does not exist as well. Now let's solve for the whole or the discontinuity. For the whole, we'll see if there is a common factor in the function. In this case, we have x minus 3. So you take out the common factor, you equate that one to 0. Using addition property of equality, this will give us the value of our x is equal to positive 3. Now we have another factor that is left in here, that's x plus 2. Let's equate that to y. So 3 will be substituted to our x. This becomes 3 plus 2 equals y, or y is simply equal to 5. So combining these two, your whole or the discontinuity, or there is a discontinuity in your function at point 3 and 5. Do you follow? Do you have questions? Do you have questions? Anybody from the group? Right, I think there's none. So let's proceed with another example. Let's try to solve this rational function f of x is equal to 1 over x minus 1, right? Before this and before I forgot, so we still have to graph this function. Now in graphing rational function, you can make a table of values and then you connect your ordered pairs in the graph. But there is an easier way to do that. That is by using an application. Okay, I hope that you guys are familiar with this one. Are you? It's called Demos calculator. So we just have to write down here our function. In the given example, our function is y is equal to x squared minus x minus 6 all over x minus 3. So this is how your function or the graph of your function will look like. It's more of a linear. Why? Because if we will simplify this, if we will factor out the numerator, then we can have x plus 2 alone, this one. So in its factored form, cancel x minus 3, we're left with x plus 2, and that is a linear function. Okay, now let's continue to our second example. 1 over x minus 1, so this is simplified already, so we do not have to factor this out. Let's go directly with the domain. Actually, we can find the domain by simply looking at the denominator. Take note, we have x minus 1, so the possible value of x that will make the function undefined is 1 as well. If we have here 1 over 1 minus 1, this gives us 1 over 0, which becomes undefined. So you can just take a look at it, but if you don't want, still write down the denominator, you equate that to 0, and you apply the properties of equality. This gives us the restricted value for x is 1. So your domain will be all the values of your x that is an element of real numbers, provided that x is not equal to 1. Now let's continue with the intercepts. We have here intercepts. Right, for the intercepts, let's begin with the x-intercept. So write down first the function, replace f of x by y. We have y is equal to 1 over x minus 1, and we'll have to let y be equal to 0. 0 is equal to 1 over, right, not y, x rather, since this is Okay, x-intercept. Okay, that's good. Y is equal to 0 and we have x minus 1. Now we need to remove the denominator, so we'll multiply both sides by x minus 1, x minus 1. 0 times x minus 1, that's 0. And on the other side, we are left with 1. Take note that we're left with 0 and 1. The variable x is eradicated. This means that there is no x-intercept, or the x-intercept does not exist. Now let's continue with the y-intercept. Let me write it here, y-intercept. Write down the function y is equal to 1 over x minus 1. Now let's go and get a value of our x. We suppose that is 0. So y is equal to 1 over 0 minus 1. This gives us y is equal to 1 over negative 1, or simply y is equal to negative 1. Again, your x and y intercept, if there is, should always come up with the abscissa and the ordinate. The abscissa is your x value, the ordinate is the y value. So we have here 0 and negative 1. This will be your y-intercept. So let's proceed to finding the zeros. So again, we don't have to solve for the zeros, just copy the x value on your x-intercept. In this case, we haven't found an x-intercept. This means that there is also no 0 or zeros. We'll jump to our asymptotes. Right? Asymptotes. Starting with the vertical asymptote, or the VA. So first, we need to check if there is a common factor for the numerator and the denominator in these functions. So in this case, there is no. Now we can simply copy the restricted value of x in the domain, which gives us that the vertical asymptote is at x is equal to positive 1. Now, let's have the horizontal asymptote. So we have to compare the degree, or the highest degree in the numerator, that is 0. The highest degree in the denominator, that is 1. 0 is less than 1. So we'll have to check the form. Degree of denominator is less than the degree of denominator. This gives us y is equal to 0. So y is equal to 0. This will be our horizontal and vertical asymptotes. Now, let's continue for the whole. For the whole, again, this will only exist if you can see a common factor from the denominator and the numerator of your function. But in this case, we cannot see. There's no numerator that will be cancelled except 1. This means that there is no discontinuity, or the whole does not exist. Now, what does its graph looks like? So we'll just have to write down the function in our graphing calculator. That's 1 over x minus 1. So this is how your graph looks like. Now, whenever I will ask you to graph a specific function, you can just simply use this graphing calculator. Because if you'll be using table of values, the same lang gihapon ang result, and then I don't like watching or looking, staring at your graphs na magkabaliko-baliko and then malabad. So I will be advising you to use this starting now. Okay? Do you have questions? Do you have questions? Right? I think there is none. Now let's have another problem to solve for. Let's say that your f of x is equal to x squared minus 4 all over x squared minus 9. So this can be factored out. Let's see. Let's look for the factored form. For the numerator, this is a perfect square, the same with the second term. So let's see. Let's have the factor of x squared, that's x and x. The factor of negative 4, that once combined, the result will be 0. So we can have positive, and negative 2. Why? Positive 2 times negative 2, that is negative 4. Positive 2 minus 2, that's 0. It's the same on the denominator. The common factor or the factor of x squared is x times x, and the factor of 9, we can have 3 and 3. So what sign should we be using in here? We can have positive and negative.
Negative.
Positive 3 times negative 3, that is negative 9, and 3 minus 3, that is 0. Now let's go and look for the domain this time. We have the domain. Write down the denominator. That's x squared minus 9 equals 0. Using the properties of equality, this will give us x squared is equal to 9. Taking the square root of the 2, this will give us the value of our x, that's positive and negative 3. So it means that positive and negative 3 will not be part of our domain. Or you can also find the restricted values of x in the factored form. Let's have the factored form of the denominator that's given by x plus 3 times x minus 2 will equate that to 0. Now separating these two factors, we have x plus 3 equals 0 and x minus 2 equals 0. So this gives us x is equal to negative 3 and x is equal to positive 2. Oh, positive 3. Wait, I have something in here. This should be negative 3. The denominator, this is not 2. It's 3. Okay? So this is 3. So we have the same results in here, positive and negative 3, negative and positive 3. This means that your domain are all the values of x, which is an element of real numbers, excluding positive and negative 3. Or we can write that one and do this in the set notation. X is an element of real numbers where x is not equal to positive and negative 3. Now let's continue on the intercepts. For the intercepts, let's begin with the x-intercept. Okay, write down the function, change f of x to y, and copy the numerator and the denominator. X squared minus 9. So we'll set x be equal to 0. Y. And we have x squared minus 4 over x squared minus 9. Now we'll have to eradicate the denominator, that is by multiplying both sides with the denominator. Okay, x squared minus 9, x squared minus 9. X squared minus 9 times 0, that is simply 0. And on the other side, we're left with x squared minus 4. Applying the properties of equality, this will give us x squared is equal to 4, and we take the square root of these terms, we have x is simply equal to positive and negative 2. Now, your x-intercepts will be 2, 0, and negative 2, 0. Now, let's proceed to our y-intercept. Right, y-intercept. So let's write down, change f of x to y. Y is equal to x squared minus 4 all over x squared minus 9. Substitute 0 to x. This gives us 0 squared minus 4 over 0 squared minus 9. So y is just equal to negative 4 over negative 9. Or negative 4 divided by negative 9, both negatives, the sign the same. So we'll have 4 over 9. This gives us our y-intercept. It's simply 0 and 4 over 9. Now let's have the zeros. So for the zeros, just simply copy the x values on your x-intercept, that is positive and negative 2. So your zeros will be x is positive 2 and x is negative 2. Now let's go and continue. We'll have the asymptotes. Right, asymptotes. Starting with the vertical asymptote, we just have to check if there is a common factor in our function. There is none, so we can directly copy the restricted values of x. That's equal to x is just simply positive and negative 3. Now let's have the horizontal asymptote. Let's compare the degree for the numerator and the denominator. So the highest degree of numerator, that is 2, the highest degree of denominator, that is 2. So since they are equal, we'll have to see in here, once the degree for numerator and denominator are equal, we'll have y is equal to a over b. So we'll continue this one here. Here now, okay? We'll have y is equal to a over b. Our a here is the leading coefficient of your numerator, which is 1, and our b here is the leading coefficient of denominator, which is 1 as well. This gives us that the horizontal asymptote for this function is positive 1. Now let's continue this. Let us have the holes. We'll check if there is a hole or holes. In this case, we'll see if there is a common factor, but we cannot see a common factor for the numerator and the denominator. This means that the continuity does not exist or there is no hole for this particular function. Do you have questions? Okay, let's try to graph this. Y is just equal to x squared minus 4. We'll have to erase this. X squared minus 4 all over x squared minus 9. So this is what your graph looks like. Or if you want it like this is what your graph looks like. Now let's go back to our solution. No questions? I think I've heard nothing, so let's go and try this one. Let's have, let's try to use, suppose that your f of x or your y is given by the function let's say x minus 2 all over x plus 2. So go and try to solve this. You have a few minutes to
Ma'am, pwede na
answer
ako
this
may
one.
atong last example, ma'am.
Yes?
Pwede na ako may screenshot atong last example nimo.
Yes, you can go and take a screenshot of this.
Thank you, ma'am.
Okay.